Yo guys, what's popping? Today we're going to be making another lit video, so let's just jump right in.
Alright, you've got your new notebook for Unit 2. We're on page 6, 2.1, Hypotheses and Sources of Data. We have a little warm-up exercise there. You're going to answer each of the following questions in your head, and then we'll share our answers together. The question is, who is the richest person in the world?
Bill Nye.
In your head,
Or Bill Gates.
in your head, and then say it. Who do you think? Maybe Bill Gates? Maybe the guy who owns Amazon? Bezos is the CEO of Amazon. Bill Nye. It's not Bill Nye.
Donald Trump.
Warren Buffett is up there. Good. Next question. Can you throw a ball farther on Earth or on the moon? Don't say your answer. Can you throw a ball further on the moon or on Earth? What do you think? One person. Ronnie. Earth? Moon? Moon? Earth? Okay. Next question. How are your marks affected by the amount of time that you study for a test? How are your marks affected by the amount of time? So what's the relationship between your mark and the amount of time you spend studying for a test? Jaden, what do you think?
I don't know. Nothing.
Olivia?
The more you know, the higher chance you have of getting things right.
Okay, so the more you know, the more higher chance, and you know by studying, Ronnie? Strategy?
Yes,
Strategy, so it's a good strategy to study for your test, because your marks will go up. Okay, good. We don't need to necessarily know the answers to these questions, but each of your answers to these questions is called a hypothesis. 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 If you have a hypothesis about anything, the richest man, whether you can throw a ball on Earth or the moon or whatever, it can be tested. It can be tested and proven to be either what?
True. Right or
Either
wrong.
true
Or false.
or false.
Not true. Can you please tell us the answer to number 2 mystery?
Alright, we're going to take a whole bunch of notes here for a second. We're going to get some definitions, and then we're going to dig into our examples. We're going to bounce back and forth a little bit between examples and notes. So make sure you don't write too big. You're going to have about 4 definitions under the heading that says notes there, okay? So here we go. We've got hypothesis as your first one. Hypothesis. And this is a statement or theory. Statement or theory that is either true or false. So if you said that you could throw a ball further on Earth than on the moon, that is false. Depending on the restrictions put on you by your astronaut suit, I guess. The next word that we're talking about is statistics. Statistics. And this is numerical data. Guys, catch yourself. Numerical data or the collection, organization, and analysis of numerical data. So, as a noun, it's just numerical data, okay? So, anytime you get numerical data, it's statistics. Like if you know how many points, goals, and assists Sidney Crosby got in this season, that's a statistic, okay? It's just numerical data. When you study it, when you collect it, organize, analyze it, you're doing statistics, okay? Verb-ish. Okay, so we have a definition for hypothesis, and we have statistics. Now we're going to kind of scroll down to example 1 and do that together. So we've got example 1, and it says, state a hypothesis and its opposite. So write a hypothesis about a relationship between the variables in each pair. So each pair, A, B, C, there's going to be two variables. And then we're going to write a hypothesis about it, and we're going to give an opposite hypothesis. Okay? So in A, think about this and try it on your own. Think of a hypothesis. A driver's age and the risk of having an accident. How are those two variables related? The driver's age and the risk of having an accident. Think about it for about 10 seconds.
You waiting for?
I'll write kind of what I want you to write. Yeah? All right, who would like to share their hypothesis? Jacob.
Middle-aged drivers have the most accidents. Is that what we're going in?
Yep, sure. So the question for you there is, does your hypothesis include the relationship between all ages of drivers? You know what I'm saying?
Mm-hmm.
So as drivers get older or younger, what happens?
Older drivers is 70s if they're still driving, probably at a higher risk because they're getting older, like they may have poorer eyesight or something like that.
Okay, so we have some reasons why we think older drivers have more accidents, but we
Not
still...
necessarily more accidents, but more at risk.
They're at risk. We still haven't accounted for the whole range of ages from 16 till, 99.
Oh, I think that.
Ronnie?
I think that like 16-year-olds and like people from like when they start getting older, when they hit their like 70s and 80s, and same as like 16-year-olds too, because they're just getting new to the whole driving car thing. And
Okay, so maybe at the lower, younger end and at the higher end there's increased risk? That's true.
I think
you kind of
that
mature.
when you start to be like in your 20s and 30s, and you start to drive more carefully because you probably have kids and stuff.
So maybe middle age is actually the safest time?
Yeah.
Okay, I'm going to write a hypothesis. It doesn't have to be the answer to the question. It's just something that can be tested. Children in the back. Thanks. It's just something that can be tested. So here's an example of a hypothesis based on these two variables. As drivers age, as they get older, risk of having an accident increases. Okay, it's just an example of a hypothesis. It's a statement, and it's testable. It's either true or false. Okay? Now, we need to come up with an opposite hypothesis. So if we were going to test this hypothesis that we wrote together here, think what would be the opposite of it. What is the opposite of this statement? Think about it for a second and be ready to share. A blank stare, or are you all here? Okay. Olivia.
Younger drivers, less risk of having an accident. That's it.
So younger drivers having less risk would actually be the same as this one. It wouldn't be an opposite one. Right? If older drivers have a higher risk, then younger drivers have a lower risk. So that's actually the same as this one. That partners with this. We need something that says the opposite.
As drivers get older, they get more experience.
People who don't.
Okay, is getting more experienced part of
Middle-aged.
one of our variables? It's not. That's true. As you drive more, you get more experience.
So as drivers age, then they're at less risk.
Yeah, 'cause
That
they have,
would be
'cause they
an
get more
opposite
experience.
statement.
'Cause they get more
Okay,
experience.
right, but we're not asking for a rationale, we're asking for a hypothesis. As drivers age, risk of having an accident, what? Decreases. Now, is there another way to write an opposite statement for this?
No. Yes. No.
So we changed the second part of the sentence. We said risk of having an accident decreases. But could we have changed the first part of the sentence?
Yeah.
We could have said something like, in younger drivers, risk of having an accident is increased. Right? Does that make sense? So that would be another way to write an opposite hypothesis. All right. Go ahead and read the next part and try to come up with a hypothesis using those two variables. Using what we learned from A as well. Attendance at school and your marks. Attendance at school and your marks.
Lack of attendance will decrease your marks.
Okay. Anyone else want to put it in different words?
Yes.
Less
The,
school,
the
lower
more
grades.
the more you show up, the more it will negatively
Failure to show
affect
up
your
will
grades.
cause a failure.
The more you show up.
The more you show up, yeah, and
Less
the
interaction.
more you
go to school,
attend.
The more you learn, so the better.
No,
your
wait.
grades
The
will be.
less you attend will impact you negatively.
The more you
Yeah.
Okay, let's use the words that are in the example. The less you attend,
less infraction.
the lower your marks will be.
I said the opposite. I said the more you go to school, the more you will learn. So the
Yep,
more-
that's
the
great.
better.
That's good as well. Take out the more you will learn. Just use the variables that they've given you. The more you attend, the higher your grades. Okay? Now that's not an opposite hypothesis. That's the exact same hypothesis in different words. Now try to write an opposite hypothesis.
The better your marks will be.
Sure.
For some people, that's true. Though.
I'm going to write the more you attend, the lower your marks.
I find I learn more when I'm just out and about than being at school.
My dad.
This is just
C. The variables given are the heights of boys and the heights of girls. Now that's not a dependent or independent. It's just two variables, and you have to discuss a hypothesis about those two variables. So
Boys are usually taller than girls. Because they have a growing.
The boys will be taller than the girls.
So you could say something like, on average, boys are taller than girls. I don't know if you went to grade 1 and 2 if that would be the case. Or grade 6 and 7, or grade 5, or grade 8. Okay? Because girls grow earlier than boys do, typically. So you could use that hypothesis. Remember, it's anything. You can write anything you want, as long as it's testable, as long as you can do a study and verify whether it's true or false. So go ahead and write whatever you want for your hypothesis there. I'm going to write, on average, comma, boys and girls of the same age are the same height. Now,
No.
you can test this. It's a hypothesis. It doesn't have to be true. It could be false. There's a lot of other things you could test using just these two variables, but this is just one example of a hypothesis. Go ahead and write an opposite hypothesis. This one's actually a little bit challenging to write an opposite hypothesis. What are you going to write for your opposite
The boys
hypothesis?
will always be shorter.
Boys and girls not the same
Yeah, not the
age
same.
will be the same.
Yeah,
That could be true.
that's a bit challenging.
Well,
Uh,
but that's like the opposite, right? Or is that?
Use the word not, but put it in a different place. So why is it not the opposite to say boys are always taller than girls?
Because
Because then there's
it doesn't have
another
anything to do with the
option.
first thing.
Girls could be taller than boys. We need to negate the first hypothesis.
boys and girls will not be the
Okay.
same height.
Boys and girls, on average, boys and girls of the same age are not the same height. Now, which of those statements do you think is closer to being true? Probably the first one. Except for adulthood is a large portion of your life, and that wouldn't be the same necessarily. But there will be a general correlation, right? They both grow and then plateau.
Do you
Boys and
shrink?
girls.
Like, is that like a thing? Like, do you actually
Okay, looking back to your notes on the left side of your page there on page 6, underneath hypothesis and statistics, guys, come back to it.
Really?
We are going to talk about data sources. data sources. So often you need data to test a hypothesis. Often you need, no, this is under your notes. You need data to test a hypothesis. You can collect primary data or secondary data. So let's define primary data. Primary data is original data that a researcher gathers specifically. Primary data is original data that a researcher gathers specifically for a particular experiment or survey. So an example of this would be like the report that I gave at the end of last semester on the legalization of marijuana. That's primary data. I did a survey, gathered the data myself. Okay, that's primary data. You're going right to the source and getting the data that you need. Okay, secondary data. Secondary data is data that someone else has already gathered for another purpose. So this is like when we would go on Stats Canada and look up, the average income of everyone living in Ontario or the average house sale cost of the people in New Brunswick. That's Stats Canada has gathered, organized, compiled all of that data, and now you're just accessing it maybe for your own purposes. It would be secondary data. You didn't go out and get that data personally. It's already been done for you, and you're grabbing it offline. It's secondary data. Okay? So we have a couple of definitions there, and now we're going to dive into example 2, which asks us to identify primary and secondary data. Okay? Primary data, again, is original data that researchers gather for a specific purpose. Secondary data is using data that somebody else already gathered for something else. We're going to explain whether each set of data is primary or secondary, and then briefly discuss the advantages and disadvantages of each person's choice of data source. So in A, we've got Daniel. He telephoned 100 families in his town to ask them how many pets they have. Primary.
You can see he's doing it himself.
Good. Now, Daniel wants to know how many pets people in his town have. Is this a good way to do it?
No.
No.
Can you think of a better way to do it?
Yeah.
Surveys?
Isn't that what he's doing?
Online survey.
Good, bro.
He could find,
How could he get the people in his town to access the online survey?
or Google Template.
Walk around with a microphone.
Google Forms?
Put it in the newspaper.
Put it in the newspaper?
Ads.
Facebook?
Door to door.
Door to door is faster than telephoning?
Yes.
Okay, so
Because how do you even wake up?
so it's good
Because
to
you have a
discuss.
family like my family that doesn't pick up the home phone ever.
Then he'll just call someone else.
And you get it like
We have a pet, so then his data would be wrong. We have
Uh,
multiple pets.
Is 100 people all of the people in town?
Oh, yeah.
Yes.
No, it's just a sample of the people in town, which we
Well,
get
we
into
miss
a little
out
bit
on
later.
all three of
Okay, so
them.
I think his way of doing it is acceptable. You might
Yes.
think of a better way, and that's okay. B.
And, resting.
B. Read B for us, please. Kathy used B. Kathy used data from Stats Canada to determine the proportion of households in Canada that have at least one car. Primary or secondary? Secondary. Benefits or negatives to her strategy?
Faster,
It's fast, it's easy.
but it may not be 100% accurate.
Well, no, it's Stats Canada.
I would
Yeah,
say
the
I would say
internet-
it's very
the internet
trustable.
lies.
That's
Yeah.
the same as that.
It's pretty trustable information. C.
That's North Korea.
Anna found a website with the results from a survey on the spending habits of teenagers across Canada. Primary or secondary?
Secondary.
Secondary.
And any pros and cons to her strategy?
Yeah, it might not be very accurate.
Might not be a reliable source, right? It just
Might have
says
been Wikipedia.
just says a random website on the spending habits of teenagers across Canada. They might not have done a very good job of collecting their data, which we learn about in the next lesson. Okay? Good discussion. D. Thomas checked the websites of 24 stores for the price of the latest... Oh,
Chronic.
It's
That's
12.
primary.
12 stores for the price of the latest iPhone.
That's primary.
'Cause
Primary?
he found it.
Yeah, he went to.
No, yes, yes it is.
And do you like his strategy?
Yes?
Yeah. If you go up.
All right, the homework for this lesson is grouped with 2.2, which we're going to do right now. So go ahead and hit the next video, and you'll be on lesson 2.2.
Ooh, are you making?